We've been working on chapter 15 and we've seen so far triglycerides and phospholipids. We're going to take a quick look now at vitamins and steroids. Mainly you just need to be able to recognize those types of molecules. And notice these don't contain esters, so that's something that we'll be missing as we look at these molecules. So we're going to look first at steroids. I think maybe of building muscle and bodybuilding when I hear steroids, but it's actually just a shape of molecule that is recognizable and a pattern that nature uses over and over again. Cholesterol is actually a steroid, and can you notice this 4-ring, we call it 4 fused rings, shows up in all of these molecules. So cortisone, or cortisol as it would be a hormone in our body, you might buy this to reduce inflammation at the store, but we have cortisol that we make in our bodies as well. That's a steroid too. And then our sex hormones like testosterone have that same steroid 4 fused groups there. Now remember, all of these are lipids, right? And lipids, the uniting feature was that they're non-polar. And as I look at these molecules, do these look like the majority of them is non-polar? There might be a couple of oxygens, but it's mainly lots of carbons, right? Tons and tons of carbons. So that's why these molecules fall into the lipid category. And we don't see any of those esters, right? There's no carbonyl with an oxygen next to it, so I don't see any of those. Note the name here, cortisone or testosterone. That should remind you of the functional group ketone. And I do actually have a couple of ketones here that you can see. Cholesterol, when you see that all at the end, you should be thinking, that sounds like a hydroxyl or an alcohol. And sure enough, here is a little alcohol. Remember, cholesterol, we said, showed up in the cell membranes. It added a little bit of rigidity, so it was these little blue molecules here. In the cell membrane, the cholesterol would be found with its OH out on the surface by the water, and the rest of this would bury itself in where it was alike the tails of the phospholipids. So molecules kind of orient themselves to where it's most favorable. So those are steroids. Be able to just recognize those 4 rings and know at least that these 3 compounds are steroids. On our vitamins, we talk about fat-soluble vitamins. So again, fat-soluble is another way of saying it's going to be non-polar, lots of C's and H's. Our vitamins that are fat-soluble are A, D, E, and K. I will probably not tell you the name of them if you see them on a quiz or on a test, but if I look at each of these structures, again, you can see that the majority of them by far is built out of C's and H's, right? That's what my nonpolar compounds are all built out of. These are going to be transported with fats. They're going to be stored with fats. They will tell you sometimes, like if you have oil on your greens, when you eat your greens, you'll absorb these better because these vitamins will all dissolve out of the greens into your oil, and then they're able to move into your body. So these being fat soluble is something that you would think of from a nutrition standpoint. Also, you don't have to take them in every day because your body can store like a long-term storage of them, and you have to be careful not to eat too much of them because you will store more than you should. Now, for transporting things like cholesterol around in the body, things that are non-polar, this isn't going to dissolve well in water. So the very last thing we're going to look at to transport these is this molecule here. This is called a Lipo Protein, and you've maybe heard of these before in terms of measuring cholesterol. High-density lipoproteins and low-density lipoproteins carry different types of cholesterol around. In this molecule, this would be like our cell membrane a bit that we saw here, but smaller than a cell, I think. And so these phospholipids would arrange themselves on the surface. So you can see here, it's a phospholipid monolayer, and it actually should maybe remind you a bit of those micelles that we drew at the beginning of the day. The micelles were built out of soap molecules with just a single tail, and then here we're looking at a similar transporter, but each of these phospholipids has 2 tails instead. And then on the inside, this is where my nonpolar stuff goes, right? And the nonpolar stuff here is going to be my cholesterol. So the cholesterol ends up burying itself inside of this, and now my lipoprotein, which is polar on the outside, is able to carry these non-polar substances throughout your body. So we need special transporters to take these lipids around in our bodies. So this page, be able to recognize your steroids, look at a molecule like this, tell me, is it polar or non-polar? Is it fat soluble? Is it water soluble? And then just know the very basic structure of a lipoprotein.